This lecture is on subsidies for renewable power generation, why they might be, what are the benefits of them, what are the drawbacks of them, how do we think about when to build a wind farm, solar farm, etc. So the agenda, we're going to look at an example of the decision to build a wind project. We're going to talk about subsidies for renewables, the types of subsidies that exist. We're going to look at subsidies versus taxes and the valuing renewable generation. So an example of when to build a wind farm. Suppose you have a firm and the firm is considering whether to build a 25 megawatt wind project. The project lasts only 2 years. The price it can sell electricity at in the first year will be $50 per megawatt hour, and the price in the second year will be $60 per megawatt hour. It will generate $80,000 80,000 megawatt hours per year. It costs $45 million to construct the project, and operating costs are $10 per megawatt hour. The firm's discount rate is 7%. The installation cost is paid at the beginning of the year, the first year, and all profits are received at the end of the year they are earned. So write down an expression for the firm's profits if it builds the project. So what's that going to look like? Well, we've seen these before. The profit is equal to the negative of the fixed costs, minus $45 million, plus the first year discounted price minus marginal cost times the production, so 50 minus 10 times 80,000 megawatt hours, plus the second year discounted, so we have 1 over 1.07 to the second power, which is the discount rate raised to the second time period, times the price in the second time period minus the marginal cost times the production. That would be the profits. That's going to be terribly negative, so it's not very useful. It's also not very common to have a wind farm that lasts only 2 years. So now suppose the project lasts 25 years and the price is $50 per megawatt hour in all years. So we're going to make it a little more simple. What can we use to calculate this value? We can use the annuity factor. For a stream of payments of size x over the next t years, the present value of these future payments is given by present value equals x times the annuity factor, where the annuity factor again is 1 over r times 1 minus 1 over 1 plus r to the capital T, where t is the end time period. So using this formula, we get profits are equal to negative 45 million plus the present value, which is equal to negative $7,708,534. So it's not profitable. What if the discount rate is 4% instead of 7%? At the lower discount rate, the project makes $5 million. So this kind of highlights that investments in wind and solar generation are sensitive to the discount rate. This is the same for any investment decision, really. But the profitability is sensitive to the discount rate, and firms should discount the future at the rate they can borrow money. This is referred to as the firm's cost of capital. In other words, what's the interest rate on the loans they can get to build their wind farms. They also have uncertainty over what the future prices and production will be. They don't know how much production they'll have. This is a real problem for renewables, not so much for coal and natural gas. They can assume they can produce at full capacity whenever they want. Wind and solar, not so much. It depends on it being sunny and windy. But this can somewhat be buffered with long-term contracts because sometimes production is relatively easy to predict. There's several different types of subsidies for wind and solar. We have 4 major ones: wind production tax credits and solar investment tax credits. These are direct subsidies for wind and solar investments. We also have renewable portfolio standards, which we'll talk about in a moment. Higher feed-in tariffs for renewable generators. Again, we'll talk about that in a moment. And net metering for rooftop solar. Fossil fuels also have subsidies. The primary ones are we do not pay for negative externalities from greenhouse gas emissions. They also do not pay for negative externalities from pollutants, from other pollutants, so local pollutants. There's also smaller production-oriented subsidies, but the big ones are really the pollutant subsidies. These are implicit subsidies in the sense that they're externalities that are not paid for. So let's talk about the subsidies for renewables. We have renewable portfolio standards. These are common state-level policies where retailers are required to purchase an increasing fraction of their electricity from renewable generators. So the state basically says if you, let's say you're the utility for Fort Collins, the state says you have to purchase maybe 30% of your electricity that you're supplying to your residents. 30% of that has to be coming from renewable sources. They can up that to 40% in the following year and 50% in the next year and so on. So it's just a fraction of renewable energy that's supplied to a given region. And generators using renewable sources receive 1 renewable energy credit, or a REC, for each megawatt hour of electricity produced. They can retailers then purchase these RECs from generators until they meet their state requirement. They turn them into the state. So this is essentially how we're subsidizing the renewables. Each megawatt hour of electricity produced from a wind farm produces one of these RECs, and then those RECs are then sold to the retailers. The sale of the RECs provides an additional revenue source to the renewable generators, like a subsidy, while also implicitly taxing fossil fuel producers. So if the fossil fuel producer is responsible for purchasing the RECs, then it's a tax on them. Many European countries use what's known as a feed-in tariff to subsidize renewables. These are fixed wholesale prices for renewable generation, and they're typically set above the average wholesale price in the market. So if the coal plant produces electricity at $30 per megawatt hour, then the fixed feed-in tariff says, well, if you're producing from wind, then your price will be $40 per megawatt hour, for example. The additional costs of the feed-in tariff are passed on to electricity consumers through higher rates. We also have net metering subsidies. This is on the small scale or residential solar. Net metering refers to how consumers with rooftop solar panels are compensated for the electricity they generate. This allows households to sell electricity back to the grid at their retail price, which is much higher than the wholesale price. So this is somewhat controversial, and we'll talk about this later on. Evaluating renewable energy subsidy programs. These subsidies are likely not the most efficient way to reduce greenhouse gas emissions. In the subsidy programs, all non-renewable energy sources are treated identically, but all non-renewable energy sources do not have the same emissions profiles. It may lower electricity prices by shifting the curve to the right. So we'll see an example of this in a moment, but you can think of it as you're artificially reducing the price of electricity, which is going to increase the demand. And these lower electricity prices hurt some types of generation with low emissions. It makes it harder for them to compete. So let's look at a subsidy versus tax example.